Hello and welcome back. In this ampoule, there is quite a bit of a very unique fuming compound. It is iodine monochloride. In this video, we will cover its synthesis and some reactions with this unique compound. So let's start with the synthesis of iodine monochloride. So to make it, we only need two ingredients. Two halogens, in fact. The first one is iodine. Iodine resembles this little dark balls in the vial. In its solid form, it looks almost metallic, but when melted and heated, it produces gorgeous, vivid purple fumes. So to start, I went ahead and weighed out 30 grams of iodine. Iodine is pretty dense, so it looks like there isn't that much of it. Okay, so now we have the iodine. The next reagent we need is another halogen, and this is much more active chlorine. But I don't have chlorine just lying around ready to be used, so I'll have to make it now. Chlorine is easily made in numerous ways, but I opted for reaction of potassium permanganate and hydrochloric acid, as I had both of them on hand. Okay, so now it is time to make the iodine monochloride. I began by setting up the apparatus. As a reaction flask, I chose this two-necked flask and poured in all of the iodine. Next, it was time to set up the chlorine generator. So to another flask, I added about 10 grams of the permanganate. Above the flask, I then added a pressure equalizing addition funnel full of hydrochloric acid and finally a gas adapter. The acid will drip onto potassium permanganate below and react, making chlorine gas, which will be fed into the reaction flask with iodine. And there it will react to form the iodine monochloride. I didn't have a gas inlet adapter, so I had to improvise. I DIY'd this contraption out of a glass pipette, and it worked really well. I then also added a condenser to the other neck of the flask to just in case condense anything that would boil. Okay, now let's have a look at the whole apparatus last time before we start the synthesis. So we have our reaction flask with iodine, and on it a condenser and of course the chlorine generator. So now it's finally time to start producing the iodine monochloride. To do that, I just have to slowly drip acid onto permanganate to start the chlorine production. In the reaction flask, we should quickly see a color change in the gas phase from purple to reddish brown as the two halogens react to form our product. Okay, so now you're probably wondering that something's off. Like iodine monochloride sounds a bit weird. So some of you might have noticed that iodine monochloride is an interhalogen compound, meaning that it is a compound between two halogens, iodine and chlorine. But this isn't the only compound of these two halogens, as there is also iodine trichloride. And interhalogen compounds are pretty cool and unique. Anyway, we can see that the iodine in the reaction flask has turned into a brownish liquid, and that is all iodine monochloride, which is liquid at room temperature. Now we need to pass chlorine through it until everything is liquefied. Okay, so now once everything dissolved, it is now time to distill it. This is done to clean the iodine monochloride from any unreacted iodine and iodine trichloride that might have formed during the reaction. So to that end, I remove the gas inlet tube and stopper the neck. We can see our crude product. Now I will pour it into other flasks for distillation. And to the other neck, I add distillation glassware. Now it starts to heat the flask and distill the iodine monochloride. You can see its beautiful vapor front climbing the flask's walls. It was coming through somewhat slowly, so I removed the condenser and again DIY the setup to function like a short path distillation. We can see our now clean iodine monochloride coming over to the receiving flask. And that's the whole synthesis. It's as easy as reacting two elements together. So I've put all the iodine monochloride into an ampoule for storage. This way it would be fresh until I got to use it. So now it's time to do some reactions with this unique but quite reactive interhalogen compound. Firstly, we have to open the ampoule with a pair of pliers. I will pour some of it in a separate flask so that we won't have to leave the whole batch iodine monochloride out in the open air as it reacts with water in the air, which destroys it. I will only work with what I have in the flask. It seems to wet the glass very intensively. Okay, so iodine monochloride is an incredibly dense liquid with a density of 3 grams a milliliter that makes shaking an ampoule with it an interesting experience, and it also makes a funny sound. Anyway, in the open air it also readily fumes, giving off dark brownish violet vapor. So let's now look at some reactions with iodine monochloride. The first one being with 30% hydrogen peroxide. As we can see, it immediately reacts and produces iodine along with a puff of gas that is probably oxygen. After this reaction, I wanted to see if it would react with water in a similar way. It didn't react nearly as violently. It just produced some iodine. Okay, moving on. I just had to do reaction with aluminum foil because it usually reacts very violently with halogens. So I dropped a roll of foil in some iodine monochloride and got this result. Apart from initial reaction, it didn't seem to do much even when I heated it. But then I added more foil and the reaction finally started. It was very beautiful to see rich purple fumes of iodine, and you can also see aluminum burning inside, which I think is pretty cool. When I added some water to it, it immediately reacted and again made some gas. What do you think it is, hydrogen chloride or hydrogen iodide? And then it was time for the reaction with magnesium powder. I really thought it would ignite, but it didn't. Instead, it just made a little puff of brown vapor. And there is slow motion footage of the addition. I then repeated it a few more times. And I did one with a lot more iodine monochloride. And of course, we had to burn the resulting magnesium mixture that was left in the petri dish. It burned quite well. The flame was incredibly bright and the residue was also very hot. Here I dropped some water on it. And you know this couldn't be the only fire reaction in this video, so I performed a reaction that was probably never done before. I decided to drop some iodine monochloride onto burning hexamine. I didn't know what to expect, but the result was very surprising. As you can see, it severely increased the rate of burning, and it also rapidly produced this black snake, which I think is very interesting. Once again, I don't really know what it is, maybe just carbon or some polymer. If you have any ideas, write them down in the comments. Anyways, I think that this reaction was very interesting and also very cool. So that's it for the iodine monochloride. This compound is very cool and unique. It's interesting how can interhalogen compounds even exist. In the future, I'm defiantly looking forward to making more of these compounds as I really like them. So as always, thank you for watching and bye.